Good afternoon, I'm Chananchida Sukchaiya.
And I'm Suphitchaya Krachangmon.
Today we will talk about the celestial sphere.
And our observer is at Geneva, Switzerland, that is about 46 degrees north.
The celestial equator is Earth's equator projected onto the sky. It forms a great circle that divides the sky into the northern and southern celestial hemisphere. The ecliptic is the sun's apparent path across the sky over 1 year. It is tilted by about 23.5 degrees relative to the celestial equator because the Earth's axis is tilted. The moon and planets also appear close to the ecliptic. Throughout the year, Earth experienced four important seasonal points: the vernal equinox, summer solstice, autumnal equinox, and the winter solstice. This happens because Earth's axis is tilted about 23.5 degrees at its orbit the Sun. But about vernal equinox, this is around 21st month. During the vernal equinox, daytime and nighttime are nearly equal, about 12 hours each. The sun rises exactly in the east and sets exactly in the west. This marks the beginning of spring in the northern hemisphere. Next, about summer solstice, that is around 21st June. On the summer solstice, the northern hemisphere appears the longest daytime and the shortest nighttime of the year. The sun rises north of east and sets north of west. At noon, the sun reaches its highest position in the sky for the entire year. After that is the autumnal equinox, that is around 21st September. During the autumnal equinox, daytime and nighttime are again nearly equal, just like in March. The sunlight toward east and sets toward west. This marks the beginning of autumn in the northern hemisphere. The last one is the winter solstice, that is around 21st December. On the winter solstice, the northern hemisphere had the shortest daytime and the longest nighttime of the year. The sun rises south of east and sets south of west. At noon, the sun appears at its lowest height in the sky for the year. But a quick summary: equinox have equal day and night, with the sun rising to its east and setting to its west, and so this represents the 18th, the longest and shortest day of the year. The equatorial coordinate system is a way astronomers locate objects in the sky, similar to how latitudes and longitudes locate places on Earth. It is based on projecting Earth's equator and pull outward onto an imaginary sphere called the celestial sphere. The reference point of the equatorial coordinate system is the celestial equator, which is the Earth's equator extended into the space. The reference point is the vernal equinox, the direction where the sun crosses the celestial equator in March. Declinations measure how far north or south an object is from the celestial equator. It is measured in degrees from positive 90 degrees at the north celestial pole to negative 90 degrees at the south celestial pole. Declination is similar to latitudes on Earth. Next, about the light ascension. The light ascension measures how far east an object is from the vernal equinox along the celestial equator. It is measured in hours, minutes, and seconds from 0 to 24 hours. Light ascension is similar to longitude on Earth. So now, by combining light ascension and declination, astronomers can pinpoint the exact position of any star or celestial object in the sky.
In the horizontal coordinate system, we describe a star using altitude and azimuth. To find a star's declination, we observe it when it crosses the local meridian. This moment is called culmination, when the star reaches its maximum altitude Hmax. At meridian crossing, the relationship is Hmax equal to 90 degrees subtract by the differences of the latitude of observer and declination. For January, the latitude is 46 degrees, so we have two cases, the south of the zenith and the north of the zenith. For example, a star culminates at Hmax 50 degrees at south. So we put in the equation, so we get the declination is plus 6 degrees to the south. For next one is a star culminates at Hmax 70 degrees. If we try the north of zenith formula, we get a declination above 90 degrees, which is impossible. That tells us the stars must culminate south of the zenith. So we rearrange the equation again and we get the declination is plus 26 to the south. So that's how we use maximum altitude at the meridian crossing to identify a star's declination from the horizontal system. To identify the circumpolar star, we can use equation that the declination must be higher 90 degrees subtract by the latitude of observer. In January, Switzerland, the latitude is 46 degrees north. So the condition becomes declination must be higher 44 degrees. Observationally, if the star's lowest point or lower culmination stay above 0 degree altitude, it means the stars never sets. So it is circumpolar stars.